Hello friends, in this video I am going to deal with the remaining conceptual ideas from permutations and combinations which are useful for mains. See, in the first conceptual idea we discussed about the initial logics, about the counting principles, about the definition of permutation and the definition of combination. Now the second conceptual idea, here it is completely about the arrangements. See, usually we face different type of situations. We need to arrange R objects out of N objects. See, if you say these N objects are different, and while arranging we need to consider each object only once, that in the sense repetition is not allowed. If repetition is not allowed in arranging R objects from N different objects, this can be done in NPR base, and we know that the NPR is calculated by N factorial by N minus R factorial. And for suppose if repetition is allowed in arranging those R objects from N different objects, then we need to utilize the rule that N power R. Okay, see, for example, if I wish to arrange the letters of the word maths, see, since there are 5 letters, if I wish to arrange the letters of the word maths, see, for example, if total letters are utilized to arrange, this can be done in 5p 5 ways, and that is nothing but 5 factorial. If repetition is not allowed. If repetition is allowed means that in the sense there are certain words where the words will form like this. A can be used any number of times, M can be used any number of times. If repetition is allowed, then it can be done in 5 power 5 ways. So if repetition is not allowed, we need to utilize NPR. If repetition is allowed, we will use N power R. And there are certain problems in which they will ask you to find the at least one letter has to be repeated. At least one letter has to be repeated. At least one object has to be repeated. That in the sense we need to select the arrangements in which at least one letter is repeated. The total number of arrangements when repetition is allowed is N power R, and when repetition is not allowed is NPR. Then our required answer in this case is N power R minus NPR. So basically here we have 3 different situations. Arrangements of R when repetition not allowed from N different objects is NPR. Arrangements of R out of N different objects when repetition is allowed is N power R. And the number of arrangements in which at least one letter has to be repeated is N power R minus NPR. These two are a kind of arrangements. While coming for the third kind, see, the N objects are not different. Among those N objects, first suppose if you say P objects are similar. If P objects are similar and we need to arrange total N objects, this can be done in N factorial by P factorial. For suppose if I wish to arrange the letters of the word Ganga, see, totally there are how many letters will be there? There are 5 letters. So if similar objects are not there, then it can be done in 5 factorial ways. But if you observe, there are 2 A's and 2 G's. So the number of arrangements are 5 factorial by 2 factorial into 2 factorial. See, in the first case, if you observe the word maths, no letters are repeat. There are no similar objects. But if you observe the word Ganga, there are similar objects. That in the sense 2 A's are similar, 2 G's are similar. Then the number of arrangements in this case is 5 factorial by 2 factorial into 2 factorial. This is another case. And if you observe these 3 arrangements, NPR, N power R and N factorial by P factorial, these 3 arrangements are linear arrangements, whereas these 2 arrangements are circular arrangements. For example, I have N objects, and out of those N objects, I need to arrange only R objects in a circular way. See, if I wish to arrange in a circular way, then the number of arrangements is given by the rule that NPR by R. And if I wish to arrange total objects in circular manner, it can be done in N minus 1 factorial ways. And for that circle, if there is no importance for the left and right, there is no importance for the front and back, then in those cases, the number of circular arrangements will become like N minus 1 factorial by 2. And we will use this N minus 1 factorial by 2 for the flower garlands and then the pearl beads. For such type of arrangements, we will use this N minus 1 factorial by 2. So totally in permutations, we have only these 5 rules, and then with these 5 rules, With our usual common logic, we will solve many problems. What are those 5 logics? NPR, n power r, n factorial by p factorial, npr by r, and n minus 1 factorial. Okay, see, just have a look here, and then I will move to the third conceptual idea of permutations and combinations. This third conceptual idea is also from permutations. Along with these 5 basic logics, we have certain matter of problems to solve. For example, among those problems, I will say we will use string method for certain problems, and we will use gap method for certain problems, and there are certain problems in which we need to arrange objects in only specific order. There is no other choice. We don't have any choice to arrange irregularly, but a specific order is mentioned in the problem. According to that specific order, we need to arrange. See, whereas coming to the gap method, see, certain gap is mentioned in the problem. Based on that gap, in maintaining that gap, we need to arrange the objects. And string method, see, where we will use these type of methods. For example, if you say I have 4 boys and 6 girls, I need to arrange these 4 boys and 6 girls in different ways. If I wish to arrange these 10 persons in a linear way, it can be done in 10 factorial ways. If I wish to arrange these 10 persons in a circular way, it can be done in 9 factorial ways. But where we will use the string method, there are certain problems. Okay, if they ask you arrange these 10 objects such that all girls come together. See, if they say that all girls come together, see, we need to string all the girls. We need to make a pack of girls. See, if you string these 6 girls, we have a string of girls plus 4 boys. Totally I have 5 objects. 4 boys and then 1 pack, 1 string of girls. These 5 objects can be arranged in 5 factorial ways. But later among these 6 girls in this string, these 6 girls can be arranged in 6 factorial ways, and the total number of arrangements are 5 factorial into 6 factorial. Initially we have 5 objects, 4 boys and then 1 string. It can be arranged in 5 factorial ways. Later in the string itself we will arrange those 6 girls in 6 factorial ways, and that is 5 factorial into 6 factorial. Whereas coming to the gap method, if they ask you to arrange these 10 persons such that no 2 girls come together, if they wish to arrange such that no 2 girls come together, so we need to maintain a gap between the girls. There is no need to maintain the gap between the boys. So first of all, you just arrange those boys. First, see, if you arrange the boys, if you arrange those boys, it can be done in 4 factorial ways. And if you see how many gaps will be there are only 5 gaps, and you need to fill those 5 gaps with those 6 girls. It is not possible. Okay, so the question is actually not meaningful. If they ask you to arrange 2 girls come together, you don't have any answer for this. The arrangements are 0, right? And for example, if they ask you to arrange those 10 persons such that no 2 boys come together. If no 2 boys come together, you just arrange 6 girls first. Okay, those 6 girls can be arranged in 6 factorial ways. After that, how many gaps we have? See, if you count those, you will have 7 gaps. And now you just arrange those 4 boys in those 7 gaps. If you arrange those 4 boys in those 7 gaps, nothing but you need to arrange boys in 4 chances out of those 7, it can be done in 7p4 ways. See, if you arrange those 4 boys, for example, let us say these 4 places I will select. Then these places are empty. If these places are empty, the 2 girls come to sit together. No problem. Our choice is no 2 boys come together. Girls may sit together, may not sit together. So if they ask you to arrange such that no 2 boys come together, you just first arrange the girls. Then in the gaps, you need to arrange those 4 boys. It can be done in 7p4 ways, and your answer is 6 factorial into 7p4. Whereas in the first case, if they ask you to arrange such that no 2 girls come together, first we need to arrange boys. After arranging boys, we have only 5 gaps, but there are 6 girls. So there is no possibility of arranging those 6 girls in those 5 gaps. So in this case the number of arrangements are 0, whereas in this case the number of arrangements are 6 factorial into 74, right? And then when coming for the specific order case, for example, if they mention you to arrange these 10 persons such that the 4 boys can sit in a specific order, since they will sit in a specific order, we don't have a choice to arrange the boys irregularly. The boys have to sit in one specific order itself. Since there are 4 boys, if they sit irregularly, it can be done in 4 factorial ways, but they are sitting in a specific order. So every 4 factorial arrangements of the total arrangements will give us one arrangement. So your answer for this case is 10 factorial divided by 4 factorial. The total number of arrangements are 10 factorial. Okay, and among those 10 factorial arrangements, every 4 factorial arrangements represents one single arrangement satisfying this particular case. So the number of arrangements are 10 factorial by 4 factorial. So these are 3 very useful methods from permutations: string method, gap method, and then specific order case. Right? This is the third conceptual idea. Whereas coming for the fourth conceptual idea is about the combinations. Already we discussed about the definition of combinations. Combinations are nothing but selections. And see, what is selection? NCR. NCR is nothing but what we mentioned, that NPR by R factorial, which is nothing but N factorial by R factorial times of N minus R factorial. This is the basic definition and the formula of NCR. Using this we will say that NCR is equals to NCN minus R. NCR is equals to NCN minus R. I will go with an example. 100C30 is equals to 100C70. What it means? The number of ways of selecting 30 objects out of 100 is equals to the number of ways of selecting 70 objects out of 100. The number of ways are same, right? So NCR is equals to NCN minus R is one logic based on that NCR, and another one is NCR plus NCR minus 1 is equals to N plus 1 CR. Another algebraic relation on NCR. And one more thing is NCR is equals to N by R of N minus 1 CR minus 1. Just see, this is NCR, N by R into N minus 1 CR minus 1. Another algebraic relation, another formula which is very helpful in solving problems. And one more thing is, if you have that NCR by NCR minus 1, the result is N minus R plus 1 divided by R. These are the 5 very basic fundamental rules based on the rule of NCR, formula of NCR. Okay, so which are very helpful in solving the problems. Now, along with this, we have the basic definition that NCR is nothing but selections of R objects out of N objects. And for example, if you are going to select R objects out of N, if they mention that some particular objects are already included, or if some particular objects are already excluded, how to solve those type of problems? See, inclusion and exclusion of some particular objects. For suppose, what I have to say, for example, there are 100 persons and I need to select some 20 persons out of this 100. If I wish to select 20 out of this 100, it can be done in 100C10, 100C20. For example, if 3 particular persons are already included, if 3 particular persons are already, or some may say always include, out of those 100, 3 persons are already included, then how many persons will remain? There are 97, and I need to select 20 persons, but already 3 are included. Then how many have to select? Only 17. So it can be done in 97C17, nothing but 100 minus 3, C20 minus 3. And for suppose, if 3 particular persons are excluded, that means we don't have any chance to select those 3 persons. It can be done in, since 3 persons are already excluded, we have the remaining 97 persons and we need to select 20 out of those 97. It can be done in 97C20. So this is also one of the basic idea from combinations which is helpful in solving problems. So this is the fourth conceptual idea from combinations. Whereas coming for the fifth conceptual idea. The fifth conceptual idea is about the total combinations. Total combinations means, for example, I have n objects and I need to select any number of objects plus any objects. I need to select any objects and any number of objects. How many objects I have? N objects I have. For example, I need to select some objects out of those n. I may select 0 object, 1 object, 2 objects, 3 objects, any number of objects. And if I wish to select one object, I may select any of the object. See that in the sense I have a chance of selecting any object and a chance of selecting any number of objects. See, if there are n different objects, then it can be done in, I may select 0 objects, I may select 1 object, I may select 2 objects, or I may select total n objects. That in the sense it can be done in these number of ways, which is equals to 2 power n. If I have n different objects, it can be done in 2 power n ways. If I have n same objects, for example, if I wish to select no object, it can be done in one way, selection of no object. If I select any one object, since those n are same, I don't have any other chance. I wish to select one object, it can be done in only one way. If I wish to select two objects, all are same, so I wish to select two objects, so that is only one way. So then, since here we don't have a discussion of selecting any object, we have to concentrate on the number of objects, because all are same. There is no discussion of selecting any object, since all objects are same. So it can be done in 1 plus 1 plus 1 plus 1, how many ways? n plus 1 ways. Since n objects are definite, the total combinations, total number of selections are 2 power n. If n objects are same, then the total combinations, total number of selections are n plus 1. And for suppose if I have p different objects and then q same objects, then the total number of selections or combinations from these objects is nothing but, since p are different, it can be done in 2 power p ways, and q are same, it can be done in q plus 1 ways. But these are the total number of combinations. Okay. If they ask you to select at least 2 objects and n are different, since we need to select at least 2 and n are different, the value is nc2 plus nc3 plus and so on ncn, since they mentioned that at least 2. And n objects are different. If they ask you to select only 3 objects, then that value is directly nc3. Okay, so this is the basic idea, and if you have a confident clarity about this logic, you will use it in many cases, right? This is the total number of combinations case, 2 power p into q plus 1. For example, there are 10 different pens and then 5 same pencils. How many total number of chances I have to select from those 10 different pens and 5 same pencils? It can be done in 2 power 10 into 6 ways, right? Using this total combinations, we are going to generate the formula for the number of factors. See, for example, if I have a number like this, n is equals to some 2 power 4 into 5 power 3 into 7 power 2. This is the number. Then number of factors for this number n, total number of factors. Number of factors. A factor of this number is nothing but number formed by few 2's of these 4, few 5's of these 3, few 7's of these 2. For example, there are, how many 2's are there? 4 2's are there, and then 3 5's are there, and then 2 7's are there. Among those 4 2's, 3 5's and 2 7's, you just select some 2's and some 5's and 7's, multiply those, it will generate a factor for the given number. Since there are, all the 2's are similar, since here I have 4 similar objects, the selection of 2's can be done in 5 ways, selection of 5's can be done in 4 ways, selection of 7's can be done in 3 ways. These are the total number of factors, 5 into 4, 5 into 4 into 3. Nothing but 4 plus 1, 3 plus 1, 2 plus 1. Okay, so this is the total number of factors. For example, if they ask you to find the even factors, number of even factors, since we need to select even factors, selection of no 2 is excluded. Since selection of no 2 is excluded, from 2's we have only 4 chances, because selection of 0 2's is excluded. I may select 1 2 or 2 2's or 3 3's or 4 2's. It can be done in 4 ways. And then 5's and 7's can be selected in all the possible ways. It can be done in 4 into 3. So the number of even factors are 4 into 4 into 3. Whereas the coming for the number of odd factors. Since these are the total number of factors and these are the number of even factors, and the subtraction of these two will give the number of odd factors. Based on this number of factors, sum of factors, product of factors, we have another video in our playlist. See, if you go with the playlist of our channel, we have a playlist regarding number theory. In that number theory, I have a separate video regarding the factors of numbers. If you follow it, you will get a clear idea about the number of factors, sum of factors, product of factors, and everything. Right? So this is the what you said fifth conceptual idea from permutations and combinations. Based on these factors, one regularly asked question from the examinations is, for example, LCM of two numbers. If I have LCM of two numbers is mentioned like P1 power alpha 1 into P2 power alpha 2 into P3 power alpha 3, like that, then the number of ways of selecting those number of pairs AB, it can be done in, since this is P1 power alpha 1, P2 power alpha 2, P3 power alpha 3, you just concentrate on the powers, then the number of ways of selecting the pair of numbers AB is 2 alpha 1 plus 1 into 2 alpha 2 plus 1 into 2 alpha 3 plus 1, like that. See, by knowing the LCM, we need to calculate the number of ways of selecting the pair of numbers AB. This is also the fifth conceptual idea of the permutations and combinations. See, just have a look and I will come with the next conceptual idea.